My name is Nemanja, and today we are talking about CQRS pattern in Java. CQRS is shortened for Command and Query Responsibility Segregation, and it's a powerful design pattern where read, or better say query, is segregated from write. So basically, we have two microservices. The first microservice is responsible for reading and querying data from a database, and the second microservice is responsible for writing data to the database. Since we have two microservices and thus two different databases, we will use RabbitMQ as a way to synchronize data between these two databases. Let's deep dive into a code and see how we can accomplish this. I have created two microservices. Let's first go through the write microservice. So let's start from the application.properties file, where I have defined the necessary properties for establishing a connection to the Postgres database connection. Also, I have added the configuration for the Spring Data JPA and also for the RabbitMQ. I will show you that write microservice is using Postgres database and the read microservice is using MySQL database. The point of that was to show that these two services doesn't necessarily need to use the same type of database. So let's go further. I have defined, in order for the RabbitMQ to work, we need to define a config file where we will define the exchange name, queue name, and the routing key. Routing key is something like a label to the message. The queue is the name of the queue in which the messages will go and we will be read from. We need to define the topic exchange bean, the queue bean, also the binding bean, and we need, since we are using Jackson serializer, we need to define it here as well. When we go to the student controller, I have defined the API controller with /student/write that accepts post method with student request as in a request body. It has name, average grade, and email. And it basically just passes that student request to the student service. So let's go into student service. Student service has a reference to the student repository and a student event publisher. Student repository is a JPA repository that works on student class and along as an ID parameter. And here we have created a new object of type student. Student is an entity which will be saved in a database. The ID is auto-generated. And we have set the name, email, average grade, and then we have saved that student and also send a message to the RabbitMQ. Let's go into the publisher, and this is one line method. When we convert this object of student using that Jackson serializer that we have defined in configuration file, and we pass the parameter of exchange name and the routing key. And that's basically it regarding write microservice. Let's go now into the read microservice. Read microservice. So let's start from the application.properties. We have designed server port to be 9090 to avoid clashing with standard port 8080 on which write microservice is running, since we are running both microservices on localhost. Also, I have defined the configuration properties for MySQL database. It's also running on localhost. I have defined configuration properties for Spring Data JPA and also for connection to the RabbitMQ. Okay, I have defined, let's see the configuration file for RabbitMQ. It's basically exactly the same as in write microservice. Keep in mind that these three parameters need to be the same in order for read microservice to consume messages from the same queue on which write microservice is sending messages. I have defined one API controller, student controller with /student/ID, where it has get method which accepts one ID and then retrieves that student from a student service. Okay, we find that in a database. In this read microservice, the database is MySQL. Student repository extends JPA repository. Okay, and we map that student, which is student. It's an entity class, but keep in mind that no annotation of generated value can be present here because this ID will be the same as ID in the Postgres database. So this is the information that we will retrieve from RabbitMQ and from that message. So there is no need for auto generation in read microservice. And we map that student to the student response. Student response is a record that has ID, name, email, and average grade. And otherwise we return none. And also what we needed to add to the listener microservice, we also needed to add listener to the microservice, which will listen for the messages to the RabbitMQ. In order for this listener to be active, we needed to add enable Rabbit on our main class. And what it basically do when it receives message, it just saves it to the database. And we specify the queue name here. So that's it. Let's see how we can, what happens when we run them. Let's start our services. First of all, we will start write application, but let's see the prerequisites for starting this application. The first one is to have two databases, Postgres and MySQL. In both databases, I have CQRS, right? We will delete this table. And also in a read, in MySQL, I have CQRS read. Okay, we also need to start Docker containers for Postgres, MySQL, and RabbitMQ, and it will be also useful to have RabbitMQ queue active, RabbitMQ dashboard active, so we can see which queues are available and which are not. So let's start our microservices. The first one will be the write application. So let's start it, and you will see it will immediately create a table in a Postgres database, and also it will create a queue in if we refresh the page, currently still no queue, but when we send the request to it, the queue will be there. And let's send post request to the write database, to the write microservice, and it will create our student. So let's check the Rabbit message queue. Now, when we refresh it, you can see that one queue has been created and one message is in state ready. So it's ready to be read by read microservice. So let's also go to the database to see that table has been created and the data is inside, but no data is currently in the read database. So for that purposes, we will run the read microservice, our read application starting. And also we need to prepare to execute get method on it if it has been started. And I just wanted to show you the new insert into student was executed because the message from the RabbitMQ has been consumed, and as you can see, the number of ready messages are 0 because that one message was consumed by read microservice. And also when we go to the database, MySQL database, refresh it, you can see there is student and that the data from the Postgres write database was synced via RabbitMQ to the MySQL database. And if we execute the request to execute the query, we will retrieve that specific student in our which we have been added via write microservice. If you like this video and would like to see more videos like this, don't forget to like, share and subscribe.